There is a very interesting sequence 1 raised to 1 over 1, 2 raised to 1 over 2, 3 raised to 1 over 3, 4 raised to 1 over 4, and so on. There are two types of problems that can be designed using this sequence. One leads to calculus and the other one leads to inequality. We will take up the first type of problem, and this one came up in ISI entrance and also a Soviet Math Olympiad. We want to find out the largest value in this particular sequence. That's our goal. Find the maximum number in this sequence. Now, I will give you an aside, that is another problem or another idea that is related to it. If you look at the sequence of numbers of this form, 1 plus 1 over n raised to n, that is 1 plus 1 over 1 raised to 1, which is simply 2, 1 plus 1 over 2 raised to 2, which is 3 by 2 squared, and so on. If you look at this particular sequence, can you say, is it increasing, decreasing, or maybe it's wavy? That is, it first increases and then decreases, or first decreases and then increases, and so on. This is a very important historical inequality. You can definitely do calculus with it, but I'll give you a hint. The hint is, look at the inequality 1 plus 1 over n raised to n, and maybe put a greater than sign here. We just need to know whether we can write this 1 plus 1 over n plus 1 raised to n plus 1. Maybe using the normal tools of inequality like AIM-GM or AIM-GM or something like that, you can definitely try to solve this inequality. You can ask for the toolbox for Math Olympiad in the comment. We have a portal where we can add you, where new resources are added. So ask in the comment and I will add you there. Okay. Now coming back to the original problem, this is 1 times 1 raised to 1 over 1, 2 raised to 1 over 2, and so on. Let's see how we can solve this one. How we can find the maximum value of this particular sequence. We will take the help of calculus. So here is the step 1. Look at the function f of x equals to x raised to 1 over x. Can you find the maxima of this particular function? Well, to find the maxima, you have to first do the derivative. Let's take the derivative. Let's find out f prime x. How can we do that? It's a standard procedure. If you have variable in the exponent, then you take log on both sides. Maybe I can write that standard procedure. Variable in exponent implies take log on both sides. both sides. Okay. All right. So let's do that. We take ln of f of x. Ln means ln is log base e. So ln of f of x is equals to ln of x raised to 1 over x. Let's go to a new page. Ln of f of x is equals to ln of x raised to 1 over x. We can take the exponent to the left. So 1 over x times ln x. Now let's take the derivative on both sides. Derivative on both sides and use chain rule. So if we do that, we have 1 over f of x times f prime x is equal to 1 over x times 1 over x minus plus negative 1 over x square times ln x. So f prime x turns out to be f of x times 1 over x square minus 1 over x square times ln x. Now fx is simply x to the power 1 over x. So x to the power 1 over x by x square. I can take this x square as common. 1 minus ln x. So we get the derivative. It is f prime x is x to the power 1 over x minus 2 times 1 minus ln x. To be fair, if you look at the problem, we are only worried about x greater than 0 and x as integer. We are only worried about this particular case because we are interested in this sequence. So let's try that. This part is never 0 because x is positive and it's an exponent, so x to the power something. So it's never 0. The only part that can be 0 is this one. So 1 minus ln x can be 0 only when x is equal to e, which is e is the Euler constant, approximately 2.7. So we found when is f prime x, that is the derivative, 0. Well, it's 0 when x is equals to e. And the first derivative is something exponential 1 by x minus 2 times 1 minus ln x. This part is always positive. Now let's analyze a little bit. If x is greater than e, which is basically equal to 2.7 something, if x is greater than e, ln x is greater than 1, so 1 minus ln x is less than 0. So this part becomes negative. So first derivative is negative when x is greater than e. And similarly, first derivative becomes positive when x is less than e. So now we have a very clear picture. At x equals to e, the function reaches the peak, and before that it increases. So because f prime x is greater than 0 when x is less than e, which means the function is increasing, and then it decreases sort of like this way. So we are only interested in this x equals to e value. In fact, we would be interested in the number just before e and just after e. So this is 2 and this is 3. So we are interested in what happens at x equals to 2 and x equals to 3. Whichever is larger will be the largest value of this sequence. So we want to compare 2 to the power 1/2 and 3 to the power 1/3. Which one is larger? I will give you a hint. Raise everything to 6th power and compare. So can you do that and put a comment in the description which one among these two is larger, and hence which one is the largest value of that sequence. It's a very simple but interesting problem. Give it a try. And also, if you want access to the toolbox for Math Olympiad or ISI entrance, then put a comment, or you can also email at helpdesk@cheetah.com.